Hello students, welcome to WebStudyz, and today we will be covering Torricelli's law under the chapter Mechanical Properties of Fluid. So this is a very important topic according to JEE Mains and Advanced point of view. So what is Torricelli's law? It basically describes us that the speed of any fluid when it is flowing out of an orifice under gravity based on the height of the fluid above the opening we get. Fine. So this velocity, or we can say the speed of the fluid which is flowing out through that orifice, it is called velocity of efflux, which is equal to V equal to under root 2gh. This V velocity of efflux is basically our speed of fluid existing the orifice. G is acceleration due to gravity, and h is our height of the fluid above the opening. So in Torricelli's law, we have some assumption. Our first assumption is the flow of the liquid. It will be ideal. Fine. There will be no energy loss due to friction or turbulence. Also, the orifice is small and the height of the fluid will remain constant. Fine. Now, what is the importance of this? So, this Torricelli's law it basically explains us the relation between fluid leaving a hole and the liquid height in that container. Now talking about its real life application where it is used. So firstly it is used in draining water. The velocity at which water will drain from container, it will depend on the height of the water obviously above the outlet. Secondly, uh, it is used in beverage dispensers, like the functioning of that beverage dispenser. It is the example of this law only. Also, garden sprinklers, spray rate of garden sprinklers, they are the example of Torricelli's law. Also, fuel decrease in a vehicle. So the rate at which fuel is decreasing in any vehicle also represents us the application of Torricelli's law. Now, let us see the derivation. So, firstly, we are assuming here that the fluid is incompressible. Also, we have drawn a diagram for our use. So, we need to know that firstly, that Bernoulli's theorem, it basically states us that V square by 2 plus GH plus P by rho is equal to constant according to Bernoulli's theorem. Fine. Now, here speed, V is the speed of the liquid, G is gravitational acceleration, H here shows us the liquid height above reference point. Fine. Rho is density and P is the atmospheric pressure at the top of the container. In many places, we can get this as P naught. Fine. So here V is considered 0 because liquid surface drops in height slowly as compared to the speed at which liquid leaves the tank. So H is 0 and P is atmospheric pressure at the opening, H equal to 0. Fine. So if this is 0, then we can write by Bernoulli's principle G into small h plus P, that is atmospheric pressure, by rho. This is equal to V square by 2 plus P by rho we can have. So this p by rho, this term will get cancelled out and we will be getting v square is equal to 2 into g into h we will get. This is equal to v equal to under root 2gh, which is the expression for our this Torricelli's law. Fine. So the derivation was very simple and very small. So let us solve one question based on this Torricelli's law. So our question is, a tank of height 100 meters is filled with water and there is a hole at a point which is 80 meter above the ground. We need to find the velocity of the fluid leaving the hole if the acceleration due to gravity is 10 meter per second square. Fine. So firstly, what data we have? We have the height of the tank, which is capital H. We can write capital H equal to 100. Fine. And then small h we can write. Small h will be capital H, that is 100, minus we have been given it hole is at 80 meter above the ground. So 100 minus 80 we have to do, so that get the height from the reference point. It is equal to 20 small h. Fine. Now gravitational constant, acceleration due to gravity, this is 10 meter per second. Therefore, according to velocity of efflux in Torricelli's theorem or Torricelli's law or Torricelli's equation, anything we can say, we can find the velocity by the equation v equal to under root 2gh. Simply just put the values 2 into 10 into 20. The answer will be under root 400, which is obviously 20 meter per second. Fine. So the fluid will be leaving the hole at the velocity of 20 meter per second. Let us solve one more question based on this. So the question is, a tank is filled with water at a that has a hole at a height of 20 centimeter from the bottom. Fine. So the water level in the tank is maintained at a height of 1.2 meter from the base. We need to find the velocity of water emerging from the hole. So here also we have the height of that water level from the base as 1.2 meters, and the whole height of the hole, it is, we can say as x, is 20 meter, 20 centimeter is given basically, so it will be 0.2 meter. Fine. So small h, if we calculate, that is the height from the reference point, means from the hole to the topmost point up to which water is filled, this will be 1.2 minus 0.2, that is capital H minus x. So this will be 1 meter. Fine. Now using the velocity of efflux, we can write, or using the Torricelli's law or equation or theorem, we can say, we can write v equal to under root 2gh, that is 2 into g is 10 into 1 h, that is under root 20. If we solve under root 20, we are going to get 4.47 meter per second as approximate answer. Fine. So 4.4 meter per second will be the velocity of water emerging from the hole. So I hope you understood this concept well and there is no doubt. So thank you.